Hello everyone. In this video, we will do an example for expectation and variance of a discrete random variable. Okay, here the random variable is given and PMF probability mass function is also given. So these are the values of that random variable. And these are the values of PMF. So this is f of x1, f of x2, f of x3, and f of x4. Yeah. Now, the question is, what is expectation and variance? So let me quickly review these two notions, and then we go from there. So this is review. So we start with the discrete random variable. RV x with values. So let's say it has n values, x1, x2 up to xn, and probability mass function f given. Okay, then the expectation of x, so in other words, the average of the values of x, well, depending on the probability. So this is how we denote it, e of x. So this is called expectation. Well, some people call it mean, some people call it expected value. And well, there's a notation that I will use. This is mu as well. This is one of the standard notation that you'll see. So how it is defined? So we take the first value of that discrete random variable, multiply it by the corresponding value of PMF. Then second times f of x2. And this will go up to xn f of xn. Since you know the summation notation, this is basically xi times f of xi. I goes from 1 to n. Well, the notation that we are using here, ex, this is more than just one number. We can change this x inside. We can actually ask what is e of x squared. Well, in that case, what we will do, well, so far what we were doing was xi times f of xi. But if this is a square, I will multiply or square the values, then multiply with the PMF. If someone says what is e of, say, sine of x, this will be, well, I will multiply this time the sign of values to that. And in general, e of a function of that random variable is going to be sum of, well, I'm going to multiply something to fxi to PMF. But what is that something? G of xi multiplied to fxi. And well, that is where the variance also can now make more sense. The variance of that random variable, we denote it by var of x. What is it? So this is defined to be e of x minus mu squared, then find expectation of that. See here, the function that I'm using is x minus a constant. Mu is a constant. Remember that. Although to calculate that constant, we did a lot of work, but now it is constant. So x minus a constant is squared. So what does that mean? This means that I have to subtract every single value of x, mu from every single value of x, square them, and then multiply each one with the corresponding PMF, and then add them. Well, there is an alternative way to calculate. This is a mathematical fact. Well, it needs some proof. It's not difficult, but this is what you will see. So you see the definition of variance is E of x minus mu squared. But so one can show that variance also can be calculated this way. I first find E of x squared, like this value, then minus the mean, the expectation of x itself that I already calculated squared. So in this example, I'll show that how using either of those formula will give you the same thing, okay? So now we have EX variance here and this formula. So let's see this in practice. Okay. Variance of, no, first expectation of x. Well, mu is all the way. So the first value is -2. I multiply to the corresponding PMF value. The second value is 0. I multiply to the corresponding value. Third is 3 times f at 3. And the fourth one is 4 f at 4. Now let's plug in the values there, because f at -2 is 5 over 12. So it will be -10 over 12 plus this guy is 0. Whatever f at 0 is, it will multiply by 0. So this one, 3 times 2 over 12, this is 6 over 12. And 4 times 4 over 12, this is 16 over 12, yes? All of them have this common denominator. Well, this is 22 minus 10. This is 12 over 12, which is equal to 1. So what we found here is the expectation or mean or expected value of x is equal to 1. It's important because I want to use it to calculate the variance of x. So variance x, the first formula says that do x minus mu squared, then expectation of that. So here, the first value is -2 minus mu squared times f at -2 plus. The second value is 0 minus mu squared times f at 0 plus 3 minus 1 squared f at 3, 4 minus 1 squared f at 4. And if you calculate those ones, this is -3 squared 9, 9 times 5 over 12. This is 45 over 12. So I'll put the 12 everywhere because the 12 is the common denominator for this case. 0 minus 1 is -1. Squared is 1 times f at 0. So 1 times 1 over 12 is 1. 3 minus 1, 2. Squared at 4. 4 times 2 over 12, which is 8 over 12. Plus 4 minus 1 is 3. Squared it is 9. 9 times 4 over 12. This is 36 over 12. And now if we do calculate this one, this is 45, 46, and then, okay, 50, 54, and, oh, that's 90 over 12. Okay, I can simplify, but I'll leave it like that. Now, let's use the alternative formula. Well, in the alternative method, the variance of x is equal to E of x squared minus mu squared. So, I know what is mu. This is 1 squared. But I want to find what is E of x squared. Well, E of x squared needs a little bit work, but definitely will need less work than what we did before. So here, sorry, e of x squared, so it will be negative 2 squared f at negative 2, 0 squared f at 0, 3 squared f at 3, plus 4 squared f at 4. Yes, so this is 4 times f at negative 2 is 5 over 12. 0, whatever is 0, 9 times f at 3 is 2 over 12. This is 16. F at 4 is 4 over 12. Now, again, common denominator is 12. This is 20. This is 20 plus 18 plus 16 times 4 is 64. So in total, we have yes. So this is 84 plus 18. That will give me 102.12. This is e of x squared. So variance of x is 102 over 12 minus 1 squared. So if we put the common denominator there, this will be 90 over 12. And that is exactly same number that we found before. Okay. So this was for discrete. For the continuous one, we will do similar things. Let's watch the other video for the example for the complex, for the continuous one.